Good evening, everybody. This is Aniruddha, and I welcome you everyone to India's largest live learning platform, the one and only Gradeup. How are you people? Quickly let me know in the live chat section and whether I am perfectly audible and visible. That too, don't forget to mention in the live chat section quickly. This is Aniruddha, and I welcome you once again, everyone, to India's largest live learning platform, the one and only. And for the first time, hello Swamajit, hello Atul. For the first time, actually, I'm covering some top problems on SOM. I had earlier covered SOM for your SSC, JEE and AE actually, but for the first time with some top ESE problems, I have come up with uh, this particular topic, which is the highest weightage topic actually. There is sometimes actually, uh, fight in between these two subjects, that is SOM and BMC, that who is going to be the king of the subjects in ESE prelims as far especially is concerned, right? So in case you haven't joined our courses for ESE 2022, that is your vision, which is exclusively for ESE and GATE 2022. So don't forget to join it right now because some exciting offers are going on. Hello Kavya, good evening. Right. So that one we are going to have here 950 plus hours of live classes, 10,000 plus practice questions, 100 plus mock test, and 120 plus chapter wise study notes. And the post GATE guidance series daily at 7 p.m. exclusively on Gradeup platform I am going to have. And you can win some exciting goodies up to 50% off. You just have to open the Gradeup app, and on the top you will find the scratch card. Actually, just open the scratch card and you will find it and just scratch it and you can win a discount of up to 50%, right? So hope you will enjoy that. The first question is up on your screen without wasting further time. But before we start, just quickly hit the like button and share the session with everybody so that everyone can enjoy this wonderful session, right? And also it's a free session, so everyone can enjoy it freely. The first question is up on your screen. Let me know in the live chat section so that what is the answer to this question. What would be the shape of the failure surface of a standard cast iron specimen subjected to torque? So yes, absolutely correct. It's helicoidal surface at 45 degree. Very quick answer and very nice answer to all of you. It's helicoidal surface. How did you find out that surface is going to be helicoidal, beta? The surface is helicoidal because the material is cast iron. Cast iron matlab kaun sa? Cast iron means which type of material it is. Let me know in the live chat section, beta. Cast iron means which type of material it is. Quickly let me know in the live chat section. It's a brittle material, and brittle materials has this kind of helicoidal surface fracture at 45 degree to the axis of the specimen. Next question. This is a very easy question. Everyone can do it. Let me know in the live chat section so that we can move towards some. I'm starting with very easy some problems, right? And then only after that we are going to move towards some difficult problems later on, right? Poisson's ratio is defined as the ratio of absolutely correct both Samajit and Atul. So everybody knows that mu is equal to lateral strain by A and D. में क्या फर्क है? A is a cup and cone fracture, beta. Cup and cone fracture is completely different, right? What is the cup and cone fracture? Let me know in the live chat section. Anybody? Please answer her. After that, I will show you. Okay, so someone is saying B, someone is saying C. How can it be C, beta? Yeah, it's B, right? So longitudinal stress, I'm coming to your point. Longitudinal stress and longitudinal strain. Longitudinal strain and lateral strain. Yeah, it's lateral strain. That means this one by the longitudinal strain. Okay, so that is actually the value. Next question is up on your screen. Let me know in the live chat section whether that what is the failure over here. So please let me know in the live chat section that what is the correct option. Let me know in the live chat section. Fatafat, jaldi jaldi. Let me know quickly. I didn't yet receive your answers. Okay, let me know in the live chat section. Fatafat, jaldi se jaldi. So Sunil is saying B. Yes. What about the rest of the people? What about the rest of the people? Failure occurs beyond elastic limit. ruptures takes place immediately after elastic limit, ऐसे भी होता है क्या कभी? नहीं तो हम तो नहीं जानते थे, right? Failure occurs beyond elastic limit. Yes, of course we know it, because after the elastic limit only the plastic zone starts where the failure happens. But rupture takes place immediately after elastic limit. No, no, no. After this, elastic limit, there is a huge zone, where, which is actually known as the zone of the reserve strength, right? Till the ultimate point or the toughness where it is meant for. Rupture takes place immediately after elastic point is not the case actually. Permanent set occurs beyond elastic limit. Yes, permanent set means the plastic deformation which cannot be withdrawn on the withdrawal of the load. So it's 1 and 3 only. Next question is up on your screen. Let me know in the live chat section. A round steel bar of overall length 40 centimeter consists of two equal portions of 20 centimeter each, having diameters of 10 centimeter and 8 centimeter respectively. Take capital E as 2 into 10 to the power 6 kg. Yes, yes, yes. Let me know in the live chat section. So what is the answer to this particular question? What they are saying is that, okay, that क्या बोल रहे हैं वो लोग, a round steel bar of overall length 40 centimeter के बारे में उन्होंने बोल रहे हैं, consist of two equal portions of 20 centimeter each, having diameters of this and this. Okay, take E as this one. If the rod is subjected to a tensile load of 10 tons, the elongation in centimeter will be given by. So I think everybody knows, sir, how the elongation of a particular thing is given. I think no one knows better than you people. But so everybody knows what is the elongation. Elongation में हम कैसे निकालते हैं दोस्त? Okay, how do you actually calculate the elongation? But elongation is normally calculated by PL by AE. I think everybody knows it. So it's very simple actually. It overall length 40 centimeter. There are two portions. So it's basically one is 10 centimeter diameter and one is 8 centimeter diameter. So I am just pulling it with a tensile load of 10 tons. Hello Vinod. So basically it's nothing but P1 L1 by A1 EI and P2 L2 by A2 E2. Simple. PL by AE for both of this particular thing you have to do. So you will suddenly find where from this pi came. Pi will come na because of this A. When A is there, pi is also there, right? Kyun? Because A1, if I talk about, it's pi by 4 into 10 square, because it's 10 centimeter. It is written over there, right? If I talk about A2, it's pi by 4 into 8 square, right? For this one. So in this fashion it will change, but rest of the things, that's P, L and E, they are same for both of them. Look, P is same for both of them because both are axially pulled by this particular force of 10 tons. Understanding? Very good. Acha, L is also same for them, 40 centimeters a total length, and it's going to be consisting of two parts, 20 centimeter, 20 centimeter. Good evening, Devlina, right? And A is only where the difference lies. So I am taking the rest of the things as common. So PL by E, only thing uncommon in between them is the area and nothing else, right? So it's 1 by pi by 4 into 10 square, okay, plus 1 by pi by 4 into 8 square, right? So P is how much? Just put P is equal to 10 tons. 10 tons means 10 to the power 4 kg. Why I'm taking kg? Because E is in kg. That's why E is 2 into 10 to the power 6 kg per centimeter square, and L is 20 centimeter. So everything is there. Just put the values, get the answer. Okay, nothing else is required. Just let me add a slide over here so that let me add a slide so that we can explain it well for those people suppose who are not understanding. क्या हो रहा है यार, स्लाइड क्यों ऐड हो रहा है? Yeah, I think now it's okay. I think now you can see the slide. Yeah, so the point is that P is equal to 10 to the power 4 kg L. L का मतलब है आपका 20 centimeter for both of them. Yeah, it's 20 centimeter. Divided by E. E is your 2 into 10 to the power 6 into 4 by pi. Why? Because this pi by 4 will come up and it will become
4 by pi simply into 1 by 100. Yes, yes, I will surely for today, today just after this class, I will do it. That's 100% sure. Okay, I have already accumulated all the PDFs. Today was actually, I was, resting so much. That's why I was not feeling well. That's why. So 4 से ये divide हो जा रहा है. So it's 1 by pi, 1 by 25 by 1 by 16. So you people please, attend my aptitude series also if you haven't attended yet. So it's 1 by 10 into 1 by pi into this particular thing. So you can find it out. Of course, the first option is correct. The next question is up on your screen. Let me know in the live chat section. Okay. A copper bar of 25 centimeter length is fixed by means of support at its ends. Supports can yield a total. Yeah, so do attend all these sessions also if haven't attended yet. A copper bar of 25 centimeter length is fixed by means of supports at its ends. Supports can yield total by 0.01 centimeter. If the temperature of the bar is raised by 100 degrees centigrade, then the stress induced in the bar for alpha C is. So it's a very easy question. So I hope everyone can, do it. So quickly let me know in the live chat section so that what is the answer to this question and how actually you see when you are talking about the yielding support. When the supports yield, तो change क्या हो जाता है in case of this particular thing. क्या बोलते हैं उसको तुम्हारे? The stress, normally thermal stress, what do you write? You write, sir, E alpha delta T, right? This is the normal thermal stress expression you write. So what change suddenly occurs in case of this particular thing? This particular क्या बोलते हैं इसको? Yielding support. Yielding means what? When the supports themselves are coming. When the supports themselves are coming, they are yielding support. So on that occasion, what is going to be the case? On that occasion, understand, normally if you see the actual derivation of this E alpha delta T, so वहां पे जो हम करते हैं actually, so it is nothing but you can say that actually हम इस तरीके से करते हैं L alpha delta T, this is the total length. Yes, yes, L alpha delta T is the total length into E by L, something like that we do na. मतलब क्या? Normally what we do, Young's modulus is equal to stress by strain, right? So what is a strain? What is the stress? Stress is simply Young's modulus into strain. What is strain? Strain is change in length by initial length. So this is the change in length L alpha delta T. This is the initial length, that is L. So this is how normally it is done. But suppose this particular bar, it is totally in absence of the yielding support, it would have gone for an L alpha delta T expansion. But if the supports themselves are yielding by delta total, so what is the net expansion now? The net expansion now is L alpha delta T minus delta net expansion divided by L, because normally we write what? E is equal to stress by strain, right? What is strain? What is stress? Stress is E into epsilon, right? E into epsilon. Understanding what I'm trying to say? Okay. If this is E into epsilon, what is going to happen is that, आप समझ लो थोड़ा इस बात को दोस्त. If it is E into epsilon, this epsilon means normally change in length by initial length, right? Normal occasion change in length is L alpha delta T by L. If in case of yielding support, it's L alpha delta T, normal expansion. The supports are also coming close, delta. So net expansion L alpha delta T minus delta. That is the only difference, right? So I hope you can do it. So E means what? I hope everybody has understood. Once please let me know in the live chat section whether you people have understood it, yes or no. L alpha delta T. So it's 25 into 20 into 10 to the power minus 6 into delta T. Delta T means 100 degrees centigrade, right? Okay. Minus delta is 0.01 divided by L. L is 25. So let me know in the live chat section so that what is the answer coming. कौन सा आंसर आ रहा है दोस्त? D आ रहा है. चलो good. So it's gonna be yes, correct है. Okay, so it's 550, 5 into 10 to the power 4, 0.05. So it's gonna be 10 to the power 6 into 5 into 10 to the power minus 4 divided by 25. 4 into 10 to the power minus 4 हो जाएगा वो. So on that occasion, it's simply going to be your, how much is coming? 1 हो जा रहा है यहाँ पे ना. Yeah, so 1 into 10 to the power 6 minus 4, so it's coming as 16 आ रहा है. Yeah, it's coming as 16 on that occasion. Yes, correct. Absolutely correct. So 25 into 10 to the power minus 6. Okay, 51. This is the thing. The next question is up on your screen. So this is the procedure actually that I have told you. The calculation is very simple. You are saying it's D coming, so it's coming as D, right? Hello, Abhishek. Good evening. Let me know in the live chat section, sir, what is the answer to this particular question. Lead as a material used in construction has a E of. Everybody knows it's. अब क्या ही बोले यार इसका solution अब. It's such a simple question, right? So please let me know in the live chat section so that what is the answer to this question. Very simple question. I hope everybody can do it, right? So Poisson's ratio formula everyone knows. So please do justice to this question very quickly. Okay, what is they have told actually the bulk modulus is given to you. What is given to you is the bulk modulus, right? And you have to calculate the Poisson's ratio along with this E is also given to you. तो आप लोग definitely जानते हो that E is equal to होता है 3k into 1 minus 2 mu. So from here you can easily get what is E, sir. E is 15 GPa. Okay, the units are all same. 3 into 15, 1 minus 2 into mu. So it's actually going to be your 1 minus 2 mu is equal to 0.1. So mu is 0.45. Yes, absolutely simple question. Next question is again up on your screen. This is also a simple question. I hope everybody can do it. For a block with Young's modulus of its material being 210 GPa to a stress system as shown in the figure, what is the magnitude of stress sigma for no strain along AB? Okay. So in case you are not able to see the figure properly, you are welcome to see it. Okay. फटाफट अच्छे तरीके से फिगर को देख लो that what they are actually saying. And now going back to the question, this is the question for you people. So quickly let me know in the live chat section that what is the answer to this question. Quickly now. Let me know in the live chat section. Fatafat those quickly. Fatafat. It's such an easy question. They are saying that no strain along AB. No strain along AB. इसका क्या मतलब है दोस्त? No strain along AB. बताओ भाई. 240 आ रहा है. चलो. Very good. There someone is saying 240. No strain along AB. AB means this direction. Along this direction there is no strain. What do you mean by that? It means that what is the direct stress applied in this direction is 60. 60 by E, because strain is equal to, you know, that stress by Young's modulus, minus this direction. This is also tensile sigma. So this is mu into sigma by E. This is the total stress, right, in this direction epsilon. Now they are saying it is 0. So what is the problem? It's as simple as that. It's 60 by whatever E की कोई जरूरत ही नहीं, although 60 minus E, mu is given as 0.25 into this sigma, that is 0. So from here you are getting easily 60 by 0.25. Even in absence of E you will get it. It's 240, right? It's extremely simple. Next question is up on your screen. They are saying that two planks each of 50 mm by 50 mm. They are saying section are glued together, right? 50 mm and 50 mm section are glued together along the length to form a section 50 mm into 100 mm. इसका मतलब समझ में आ रहा है क्या हो रहा है? Two sections, two planks each of 50 mm, 50 mm section are glued together along the length to form a section of 50 mm by 100 mm. मतलब है कि मानो this is a 50 mm section and another is a 50 mm section. So उसको मैंने जोड़ दिया दोनों को, right? Now this becoming what? 100 mm. This is 100 mm and this is 50 mm. Kavya, what is saying? Strain along x-axis is 0. Kavya, your previous doubt is correct or not? is got corrected na. Cup and cone and what where is asking, I think cup and cone and helicoidal fracture. वो I think it's clear, right? Cup and cone ductile material के लिए होता है. Cup and cone I think it's for ductile material, right? Ductile material के लिए होता है ना. हाँ. और जैसे कि आपके क्या बोलते हैं उसको माइल्ड स्टील वगैरह के लिए होता है. एंड फॉर ब्रिटल मटेरियल इट इज हेलिकॉइडल फ्रैक्चर एट 45 डिग्री ऐसे होता है. आई थिंक यू पीपल नो इट, राइट? राइट. So that is the particular thing that you have to mention over here. Chalo dost. So somebody is saying what, that it's 0.3. Everybody is saying 0.3, तो 0.3 होगा. There what is the maximum shear stress? तो maximum shear stress का पता तो सबको पता है 1.5 into tau average होता है. So tau average means what? Average shear stress. Average shear stress means average shear force divided by area. Average shear force is already told to you 1000. What is the area? Area is now 50 into 100. क्या ये क्वेश्चन में 1 2 3 कट गया ये. So it's 1.5 by 5, that is 0.3 MPa. Simple सी बात है. Question is clear, yes or no? Chalo, next question is up on your screen that you can see. Let me know in the live chat section quickly that what is the answer to this question. Very simple question. They are saying what is the distance of the point of contraflexure? What is the beam is actually shown in this particular figure. The distance to the point of contraflexure. ये पूछा है आपसे. Point of contraflexure. I think in the morning itself I was discussing in some part. I don't know in which batch, but some batch actually, some cases I was discussing what is the meaning of point of contraflexure. Point of contraflexure means nothing but where a particular curve changes its curvature, right? Or in other words, you can say where it is changing its sign from plus to minus in this case. That means in other words, where the bending moment is 0. Point of contraflexure means when the bending moment diagram it changes its sign from positive to negative or vice versa, right? In other words, it means that the point where the bending moment is 0. So let me know quickly, let me know in the live chat section so that what is the correct option here. फटाफट बताओ भैया, जल्दी जल्दी बता दो, टाइम बहुत कम है हमारे पास. So Somajit is finally saying it's A. What about the rest of the people? Let's see. Okay. So just find out what is the they are saying from the fixed end A, right? So let's see that any point, let's just say for example it is at a distance x. मान लो कोई दिक्कत थोड़ी है. मान लो that at a distance x the bending moment is 0. Point of contraflexion means bending moment is 0, right? At a distance of x, suppose it's happening. ठीक है. Or whether where it's 0 and it changes its sign basically. So आप बताओ यार कहाँ पे इस x point पे जो bending moment होगा, what will be that? Sir, this bending moment यहाँ पे कितना होगा बताओ at this section? 5 into how much beta? This distance is how much? This is 1 minus x, and there is one more force 8. This distance is your 0.75 minus x, and this distance is your 1 minus x, right? तो बताओ दोस्त, mx if I talk about, 1 is your clockwise, किसी को भी आप positive मानो, doesn't matter, 5 into 1 minus x minus ये anti clockwise जा रहा है, 0.75 minus x is equal to 0 because at the point of contraflexion bending moment is 0. So from here you are getting 5 minus 5x minus 6 plus 8x equal to 0. So 3x is equal to 1. So x equal to 0.33 meter. Deflection 0. नहीं यार, no. So let me know in the live chat section so that what is the answer to this question. In the analysis of beams subjected to loads, the point with nil bending moment can be देखो उसी तरह के एक दूसरा क्वेश्चन है, same type of question it is, what is given actually over here. In the analysis of beams subjected to loads, they are saying in the live chat section that the point with a nil bending moment is termed as what? Quickly. Point of contraflexure, just we have studied, right? Point of contraflexure. Point of maximum shear force, no. Point of inflection, no. Right, so it's point of contraflexure, just I have told you right now, so I think everybody can understand it, right? आप सभी को पता तो होगा. अच्छा, this is the point where it changes its sign. Acha, if I talk about what is this point of inflection, what is the point of inflection? So it's point of inflection की अगर मैं बात करूँ, what is point of inflection? Anyone in the live chat section? Point of inflection means where it changes actually the curvature, you can say. Okay. For example, it's being like convex to concave, something like that. Okay. Normally, in other cases, this is known as a point of क्या बोलते हैं उसको तुम्हारे contraflexure, but in this case actually it's point of inflection. Frankly speaking, in the mathematical terms, if I talk about, in the point of inflection, d2y dx2 is equal to 0 hota hai. This is the condition for the point of contraflexure, as well as if I talk about point of inflection both. Okay, voice breaking. Is it okay now? Let me know in the live chat section. Is it better now? Right. Last question, repeat please. Last question, this one. Last question is very simple. Point of contraflexure is the point where the bending moment is 0. So they are saying that where is the point of contraflexure? So I have from the distance, from the fixed end A. So I've assumed let's it uh, at a distance of x from the fixed end A, right? So at this point A, at this sign A actually, what is the bending moment? You just see there are two forces, one is 5 kilonewton, one is 8 kilonewton, right? So due to 5 kilonewton, what is the force? What is the bending moment at this section? This is x section. The total length is given 1 meter. This length is x meter. So it's 5 meter into 1 minus x clockwise. Second moment is given by this 8 kilonewton force upward, that is anti-clockwise, minus 8 into 0.75 minus x. This is 0.75, the total distance given. This is x. So in this section, xx, what is the moment? 8 into 0.75 minus x. So the entire moment, total moment is 0. So from there you are getting what is x, right? This question you do let me know in the live chat section. The bending moment at A for the beam shown below. Again, it's one of the very simple questions, so I hope you can very easily let me know in the live chat section what is the answer to this question. Simple questions, they are asking about the bending moment at A for the beam shown below. Achha, just to give you the good news, I think everybody has already come to know that me and Abhinav sir for the first time ever are coming exclusively on Gradeup app with the topmost questions of ESE prelims. The series name is Aniruddha series, okay, and that is currently running. That is going to run from tomorrow. Yeah, I guess not tomorrow. 5th of March. Yeah, from 5th of March, it's actually going to run exclusively on your Gradeup app, right? So we are coming very soon on that. The bending moment at A for the beam shown below not to scale is. Let me know in the live chat section what is the answer to this question. For the first time ever, we are coming together in a series, right? So Kavya has already answered C, Abhirud series, yeah. Right. So let me know in the right chat section, sir, what is the answer? Bending moment at A. So it's there is only one force at A. एक ही तो force है यार, और तो कोई force ही नहीं है, right? So it's extremely easy, 40 into ऐसा moment जाएगा. This much is 75. So what is the rest? कुछ है क्या question में बताओ एक बार. So 40 into 105, that is 4200 kilonewton mm. They could have not changed the unit. They sometimes do what? They sometimes change the unit. Suppose they have kept it 4.2 and they have given it suppose in kilonewton meter. So check that particular thing, right? So on that occasion is going to be 4.2. Right, next question is up on your screen. A machine element develops principal stresses of magnitudes 2p and p. All right. So let me know in the live chat section what is the maximum magnitude of P before the material reaches the yield stress Fy as per distortion shear energy theory. So I think you people know that there are many theories regarding this actually. The magnitude of regarding the magnitude of P and stuffs. Okay, there is maximum strain theory, there is distortion shear energy theory, there are different other theories also. So let me know in the live chat section so that what is the particular answer to this particular question, that is the distortion shear energy theory. इससे क्या आंसर आने वाला है, what we can expect actually from here. It's a very simple question, so I hope you can do it quickly. आप लोग जानते हो सर व्हाट इज डिस्टॉर्शन shear एनर्जी थ्योरी से आपको जो मिलता है, दैट इज this one is the distortion shear energy theory. Okay, half into if अगर मतलब कोई कॉन्सेप्ट का क्लास है तो मैं आपको समझा दूंगा कि ये कैसे आ रहा है, and definitely the concerned faculty whoever is there, definitely he is going to discuss everything. So this is half of into sigma 1 minus sigma 2 plus sigma 2 c तुक्का है, अच्छा sigma 2 minus sigma 3 square plus sigma 3 square minus sigma 3 square, this is less equal to the yield stress. ये होना चाहिए जो वॉट एवर इज द एक्चुअल स्ट्रेस, ये जो है इसका रूट ओवर बेसिकली, मतलब यू कैन से दैट लेस इक्वल टू द एफ वाई स्क्वायर. दिस इज द करेक्ट आंसर, मतलब ये होता है थ्योरी. नाउ दे हैव टोल्ड दैट द मशीन एलिमेंट डेवलप्स प्रिंसिपल स्ट्रेस ऑफ द मैग्नीट्यूड, क्या क्या बोला है, 2p एंड p. दैट मींस योर सिग्मा 1 इज 2p, सिग्मा 2 इज p, सिग्मा 3 मार्केट में है ही नहीं. ठीक है, चलो नाउ जस्ट हाफ इनटू 2p माइनस p whole square plus sigma 2 minus sigma 3, p minus 0 whole square, sigma 3 minus sigma 1. Okay, this particular thing is less equal to fy square. तो यहां से आपको क्या मिल रहा है जरा मुझे बताओगे, हाफ इंटू पी स्क्वायर प्लस पी स्क्वायर 6p square, 6p square आ रहा है. So from here you are getting p is equal to fy by root over 3. So option D is correct. Let me know in the live chat section whether everybody has got the understanding point, yes or no. Okay, hope everyone has understood. Let me know in the live chat section quickly. तो तुक्का कभी कभी काम नहीं आता है. So it's a very nice. I can see the options. It was B, A, C. Okay, nice. Okay. So the next question is up on your screen. Let me know in the live chat section so that what is the answer to this question. What they are saying is that a structural element is subjected to a non-dimensional, a two-dimensional stress system. Sigma 1, this one, and sigma 2 being compressive. Sigma 2 is compressive. They have mentioned it. Okay. The yield stress in both simple tension and simple compression is this much and this much. What is the value of sigma 2 according to maximum strain theory? Look, this is one another theory, maximum strain theory. Maximum strain theory is also kind of this one only. Maximum strain theory is, okay, just like it is the maximum stress theory. Maximum strain theory is that whatever is the actual strain coming, that should be less than the strain caused by the yield stress. What I'm saying, maximum strain theory क्या कहता है? Maximum strain theory is saying whatever is the actual strain coming, that should be less than the, yes, that should be less than the yield strain or the strain caused by yield stress. What is the actual strain coming, sir? Actual strain कितना आएगा? Sigma 1 by E minus mu into sigma 2 by E. Everybody knows, right? Now they are saying that is less than the strain caused by yield stress. yield stress की वजह से कितना strain होगा? Stress by E. Sigma 1, they have told it's 225, right? So it's right, you 225. अच्छा, just you can eliminate the E part and stuffs. Okay, E सब जगह से काट दो, हटा दो. But the point you have to note is that they have told that sigma 2 is compressive in nature. That means sigma 2 is minus compressive in nature, right? So mu is also given 0.25 into sigma 2 is minus sigma 2. अरे मैं बोल दे रहा हूं ना अतुल जी, अभी तो पढ़ लो, इसमें क्या दिक्कत है? ये है, देखो, ये आपके एक्चुअल स्ट्रेन इतना आता है. एक्चुअल स्ट्रेन जो है वो यील्ड स्ट्रेन से कम है. यील्ड स्ट्रेन मतलब यील्ड स्ट्रेस से कॉज्ड स्ट्रेन. यील्ड स्ट्रेस बाय आंसर पढ़ लो. आप सब कुछ अगर पहले ही पढ़ लोगे तो तुम यहाँ पे पढ़ लो, क्या दिक्कत है ना? सिग्मा वाई इज गिवन टू यू 250. तो यहां से आपको मिल जा रहा है 225 प्लस 0.2 इज 250. तो यहां से आपको मिल जा रहा है दैट इज 25 by 0.25, that is 100 Newton per meter. It's such an easy question, right? Very easy question. Just only you have to know what are the theories. That's the simple thing. Nothing else actually is there. Next question is up on your screen. Let me know in the live chat section so that what is the answer to this particular question. For the beam system as shown, for the beam system as shown, if the deflection at C is 0, then the ratio P by Q is, the ratio P by Q is, ये जो P by Q आपको ratio दिख रहा है ये कितना होगा, that is the answer to this, that is the question actually over here. Let me know in the live chat section so that what is the answer to this question. P by Q, they are saying that the deflection at C is 0. Deflection at C जो है that is 0. इसका मतलब क्या है सर? What do you mean by that particular thing? Anybody in the live chat section? Deflection at C is 0. देखो, deflection at C is happening due to two reasons. One is the load at P that is causing a downward deflection, and one is the load at Q that is causing an upward deflection. If those two deflections match with each other, then the net deflection is 0 on that occasion. What is the deflection at C caused by Q? What is the deflection at C caused by Q? तो Q द्वारा caused जो deflection that is upwards, P द्वारा caused जो deflection that is downwards. It's as simple as that. Both should be equal so that the deflection net is equal to 0. Yes, you can do it also to the strain energy principle, of course. आप कर सकते हो, but I am doing directly through this particular thing, that is deflection principle directly. भाई formula जब पता ही है तो क्यों करें हम, ठीक है ना? So delta at C due to Q upward जो है वो कितना है सर? That is Q L cube by 3 EI. यहाँ पे जो डिफ्लेक्शन है, so its deflection will be something like this, right? तो यहाँ पे कितना डिफ्लेक्शन है? That is Q L cube by 3 EI. बाकी जो डिफ्लेक्शन है, this deflection will be how much? That is Q L square by 2 EI into L. आपको पता होगा, I think, this particular thing, which is going to be your 1 by 2, 1 by 6 मतलब कितना होता है भाई? 5 by 6 लगभग होता है. हाँ, 5 by 6 into Q L cube by EI. This is the deflection at C. अच्छा, आप कल ही किए थे ये क्वेश्चन बा, ये सही है, क्योंकि मेरे तो आप लोग अगर रिलेट कर पाते हो तो आपको भी मजा आता होगा, आपको भी कॉन्फिडेंस बिल्डअप होता होगा, ये अच्छा लगता है मुझे भी. ओके, सो जस्ट लेट मी ऐड अ स्लाइड ओवर हियर, ताकि यार एक स्लाइड में ऐड कर लो, जस्ट 1 second, so that I can explain it well. Yeah, so what is the delta due to at C due to P, the up or the downward one? That is simply P, it's not L cube. Normally what is this? P L cube by 3I, but the total length is L plus L, 2L total length. So P into 2L cube by 3I. So it is P into 8L cube by 3EI. So this is the actual correct option. So let me know in the live chat section so that what is the option. So 5 by 6, okay, into Q L cube by 3I, the upward deflection, that is equal to the downward deflection caused by this. So from here you will be very easily getting what is the answer. बताओ भाई कितना आ रहा है? P by Q. So it's P by Q when we will talk about, it's coming as how much बेटा? कितना आ रहा है सर ये? 5 by 6 आ रहा था क्या? ये वाला 5 by 6 आ रहा था ना? 1 by 3 and 1 by 2. 1 by 3 and 1 by 2 मिलके कितना होगा दोस्त? 1 by 3, 1 by 2, तो 5 by 6 ही होता है. 2 by 6, 3 by 6, हाँ 5 by 6, और ये हो रहा है P into 8L cube. हाँ, तो P by Q तो आना चाहिए दोस्त 5 by 48 आ रहा है मेरा. Did I committed a mistake in any part? Please let me know in the live chat section. 5 by 48 आ रहा है कि 5 by 16 आ रहा है? 16 आ रहा है क्या? Is it coming 16, right? I think it's in your calculation, it's coming as 16, so it's very good. I don't have any problem. Okay, and P by Q actually in my calculation, why is it coming as 48? कोई एक जगह में 3 का कुछ लोचा हुआ है शायद, देखो ना एक बार, कोई जगह में 3 का कुछ तो लोचा हुआ है। ओ यस यस यस, यहाँ पे देखो मैं एक एक्स्ट्रा 3 दे दिया, यहाँ पे एक एक्स्ट्रा 3 लग गया दोस्त, इसलिए दिस इज ई आई एंड डी आई, so it's 5 by 16. Okay, next is the question. Okay, the same type of question, only what they have done is that they have just, I have deliberately kept both the questions together because there it was deflection 0. uh yes. So for the beam system as shown, if the slope at m is 0, then the ratio t by s, same type of question it is, right? Same type of question it is, only they are saying what, slope at m is 0. Always appear the sessions without revision, सब पहले से हाँ जी बिल्कुल ठीक है दोस्त, कोई दिक्कत नहीं है, but yeah, देखो, some people appear this session. I always say these are the practice sessions, so two types of people always should appear this session, I mean everybody, because the reason is very simple. One will appear for revision and the other will appear for practice. Okay, that there are two purposes simply. One is revision, that okay, I had forgotten what was that, okay, I will remember through the questions. And the second thing is that the people who have already say have the command on it, they will practice. That is the two purposes simply, right? So here actually you can see that there are two slopes. Due to this, the slope is your anti-clockwise, and due to this particular, the slope is your clockwise. So this anti-clockwise slope is going to balance the clockwise slope. It's as simple as that. So please let me know in the live chat section, sir, that what is the slope. uh, if the slope at m is 0, so what is the slope at m due to s? First of all, चलिए उस पे बात कर लेते हैं दोस्त. The s के वजह से जो slope है, that's s into l square by 2 ei, ये होगा slope. The slope at m, or I am just right, slope at m due to s, this is anti-clockwise, ये वाला slope है, and slope at m due to t, which is the clockwise one, वो क्या हो जाएगा सर? That is going to be your t into 2l square by 2ei, that is 2tl square by ei, ये होगा clockwise. Now both should be same, only then the total slope is 0, right? Another. Yes, so ei l square, so it's t by s is equal to 1 by 4. Next question is up on your screen. Let me know in the live chat section. Deflection limitations over beams are imposed because excessive deflection may cause.
Is it audible now? Let me know in the live chat section. Is it audible now? Let me know in the live chat section. Deflection limitations over beams are imposed because excessive deflection may cause all the things. Permits undesirable twisting and distortion of end connections, problems in drainage system, psychological effect users. Of course, the point is that these two, though, you can of course understand. The point is why psychological effect of the users. Okay, Yes, Atul. तो साइकोलॉजिकल इफेक्ट, आई ऑलवेज से दैट साइकोलॉजिकल इफेक्ट क्यों है दोस्त? अदर टू पर ऑफ कोर्स देयर आर अनडिजायरेबल ट्विस्टिंग हो जाएगा, अगर ज्यादा तुम्हारे डिफ्लेक्शन हो जाएगा तो प्रॉब्लम्स इन ड्रेनेज सिस्टम ऑफ कोर्स दिस आर देयर. साइकोलॉजिकल इफेक्ट इज ऑफ कोर्स लाइक दिस. फॉर एग्जांपल, मैं वो एग्जांपल हमेशा देता हूँ कि आप घर पे बैठे हुए हो, अभी फर्स्ट फ्लोर पे हो, ठीक है? आप घर पे बैठे हुए हो दोस्त फर्स्ट फ्लोर पे, फिर अचानक क्या हो गया कि इतना ज्यादा सेटलमेंट हो गया कि आप चले गए दोस्त बेसमेंट पे, ठीक है? तो आप बेसमेंट पे जाके अचानक देखने लगे कि यार घर तो नहीं टूटा. ओके, तो अगर आप सिर्फ और सिर्फ स्ट्रेंथ के लिए लिमिटेशन लगाते, तो स्ट्रेंथ क्राइटेरिया से तो आपका घर सही है, बिल्कुल सही है, क्योंकि वो टूटा नहीं है, ठीक है? लेकिन डिफ्लेक्शन क्राइटेरिया से सही नहीं है, क्योंकि डिफ्लेक्शन क्राइटेरिया से आप फर्स्ट फ्लोर में थे, फिर बेसमेंट में चले गए, आजू बाजू देख रहे हो अंधेरा घर से निकलते हुए, ठीक है? तो दैट इज ऑफ कोर्स अ साइकोलॉजिकल इफेक्ट होगा ही ना. The next question is, up on your screen, a steel plate is bent into a circular arc of radius 10 meter in the split section be 120 millimeter wide and 20 meter thick with E is equal to this, and the maximum bending stress induced is. देखो मैं हर दम ये कोशिश करता हूँ actually through this particular session so that I can touch upon every topic, so that a person who is watching, who has come to watch this lecture, actually गेट्स ऑल द टॉपिक्स. एटलीस्ट मेरे हर एक सेशन देखना, रिवीजन सेशन जितने सारे हैं प्रॉब्लम सॉल्विंग, आई ऑलवेज टच अपॉन ऑल द टॉपिक्स. अगर कोई एक चैप्टर से भी अगर होगा तो उस चैप्टर में जितने सारे टॉपिक्स है, आई विल टच अपॉन ऑल दिस. एटलीस्ट आई ट्राई. सब कुछ तो होता नहीं एक घंटे में, जितना हो सकता है यार. Next question is up on your screen, that you can see a steel plate is bent into a circular arc of radius 10 meter. The plate section be 120 mm wide and 20 mm thick. Then the maximum bending stress induced is. So I think everybody knows what is the expression of bending stress. So bending stress के expression लगाओ भाई, and get the answer done. It's very very simple. So Devlina, are you talking about this question or are you talking about the other earlier question, option D जो आप बोल रहे हो? Is it about this question you are talking about or some other question you are talking about? इसमें क्या है? इसमें तो सिर्फ फॉर्मूला ही है. इसमें क्या है और, दैट m by I is equal to E by R is equal to sigma by Y. That same formula we apply, you get the answer done. क्या ही है और. So from here actually you can get something like that, that okay sir, that sigma, if I talk about, since I have E given, I have I and R etc given to you, so sigma is equal to E into Y by R, you can see. Acha, that was of previous. Acha, E Y by R, so E is given to you 2 into 10 to the power 5. Why is it given to you, sir? Why? देखो, they are saying 120 mm wide and 20 mm thick. मतलब क्या basically? What is the steel plate which is bent into the form of a bar? It's something like that. ठीक है? So its length, its width is, that means this direction is 120, this is 20, right? तो हमने यहाँ पे घुमाया इस तरीके से. Hello Julie, good evening. After a long time, how are you? Right. So this is y. Y मतलब फिर कौन सा चीज हो रहा है दोस्त आपका? This is 20 by 2 wala y, right? And if I talk about r, r is the radius of, you can say, curvature, that is told in the question as 10 meter. So 10 meter माने है 10,000 millimeter, right? So it's 2 into 10 to the power 6 divided by 10 to the power 4. So it's very simple, 200 MPa. Next question is, up on your screen, a simply supported beam of length 4 meter is subjected to a uniformly distributed load of 2 kilonewton per meter. What is the maximum shear stress in the cross section is rectangular? Yeah, I'm fine, Julie. So do attend. This is for everyone. I'm saying, just do attend all the aptitude classes if you haven't yet in the aptitude series, and also attend. If not the other ones, at least attend the building material and construction class of this series 150 plus MCQ series that I was taking. This is the last class of this 150 plus MCQ series, and do attend my class yesterday or the day before yesterday, which was on your building material and construction, and the yesterday's class also, um, uh, which was on construction planning and management, because from these topics a huge number of questions come. That's why. And this SOM. These 3 topics है almost you can expect basically, how can I say it, 60 marks almost you can expect from these 3 topics only. Building material construction, the 60 to 65 marks you can expect from these 3 topics only. So try to understand the weightage of this topic, right? So it's very simple. It's D. या इट्स डी शायद मेरे को लग रहा है, चलिए देखते हैं दोस्त. बिकॉज दे आर टॉकिंग अबाउट यार मैक्सिमम शियर स्ट्रेस, सो बी केयरफुल अभिषेक, राइट? अभिषेक एंड बिंदु श्री, I don't know. They are talking about what? Maximum shear stress. So you know that maximum shear stress is nothing but for a rectangular section, it's simply 1.5 into average shear stress. So what is the average shear stress? Average shear stress is the average shear force by the area. Average shear force is given total 4 kilonewton per meter and 2 kilonewton per meter. Now you will ask me, sir, why? I mean, where actually this shear force needs to be taken? This tau average, when I'm taking, which value I should take? Because shear force is varied over the different part, right? If a simply supported beam is like this, okay, it's subjected to 2 kilonewton meter. तो आपका जो क्या बोलते हैं उसको, तुम्हारे shear force का distribution होगा, it is something like this, right? So it's not constant. So of course for designing you will take the highest one. कौन सा highest value लोगे आप? This particular value. तो ये value कितना होगा सर? टोटल लोड कितना है? 4 इंटू 2, 8 किलोन्यूटन. तो सपोर्ट रिएक्शन कितना कितना होगा? 4 किलोन्यूटन, 4 किलोन्यूटन का सपोर्ट रिएक्शन होगा. सो दैट मीन्स 4 किलोन्यूटन यू हैव टू टेक, नॉट 8 किलोन्यूटन. 8 किलोन्यूटन कहीं कोई भी जगह पे 8 किलोन्यूटन shear force नहीं आ रहा है आपके बीम पे. Nowhere 8 kilonewton shear force is coming. Shear force is coming maximum 4 kilonewton, right? So 4 kilonewton divided by the area. Area 100 mm wide and 200 mm deep. साफ साफ लिखा हुआ है यहाँ पे. तो 4 किलोन्यूटन को न्यूटन बना दो, 100 इंटू 200 कर दो, 4000 बाई 20,000, 1 2 3 1 2 3. सो इट्स गोना बी, कितना हो जा रहा है दोस्त? 0.2, 0.2 न्यूटन पर mm स्क्वायर. सो इट्स 1.5 इंटू 0.2, दैट इज 0.3 न्यूटन पर mm. Here a concept. I hope everybody has understood this concept. Let me know in the live chat section. And this is the problem, which is a mild steel structural section, which is actually there. It's very easy question. फटाफट मुझे इसका जवाब दे देना. A mild steel structural section is an unsymmetrical I section with a greater width at the top and a smaller width at the bottom. Okay, fine. So greater width at the top and smaller width at the bottom. Very good. इस तरीके से है कुछ, ठीक है, unsymmetrical है. The overall depth of the beam is 300 mm. Okay, very good. And the flange stresses at the top and the bottom of the beam are 150 Newton per mm square. Hello Madhav, कैसे हो आप? The overall depth of the beam is 300 mm and the flange stresses at the top and bottom of the beam are 150 Newton per mm square. It is told, ठीक है, and 50 Newton per mm square respectively. What is the height of the neutral axis? अरे यार कुछ भी है क्या क्वेश्चन में, बताओ. Let me know in the live chat section. Is there anything in the question? Just plot the diagram, आपका काम हो जाएगा. तो shear stress, whatever the diagram is, just plot it, your job is done, right? At the neutral axis, you know that it is 0, right? The stress diagram, if you follow, okay. So this is at the top, you know, if you are saying it's completion at the top, so it is going to be 150, this is going to be 50, but at the neutral axis, wherever is the neutral axis, it is 0. So just from this easy symmetry you can get it. They are saying what is the height of the neutral axis of the beam from its bottom. So let's consider if this is x. Okay, what is this height? This is 300 minus x. If you are having this x and 300 minus x, from the easy symmetry of the triangles you can calculate that simply x by 50, because these two triangles are similar triangles, right? Of course you can see these two triangles are similar triangles. This angle is 90 degree. These two angles are same, so third angle is also same. So the angles, when they are same, they are similar triangles. So simply x by 50 is equal to, you can see, 300 minus x by 150. So you can see over here that 3x equal to 300 minus x, that is x equal to 150. X equal to 75. X equal to 75. X equal to 4x 300 by 4, that is 75. So I hope everybody has got it. Let me know in the live chat section. And the today's homework question that is coming very soon. I had promised 20 questions actually in that particular thing. So I am going to do that 20 questions. So let me know first of all this question. I think everybody knows what is the answer to this particular question. Started similar thing. हाँ जी ठीक है हो गई बेइज्जती चलो let me know in the right chat section. This is a very simple question. I hope everybody can do it. A solid circular shaft has a diameter d. Its polar modulus will be. सबको पता है I think what is the polar modulus, right? So let me know in the live chat section so that what is the polar modulus. Its polar modulus कितना होगा sir? Let me know in the right chat section, sir, that what is the polar modulus. This is the last question of today. After that, a homework question we will do it. ठीक है? And after that, छुट्टी right? बता दो भाई polar modulus कितना है? Look at the units. Look at the units. D square में तो भैया कोई भी modulus नहीं हो सकता है. D square में कोई modulus नहीं हो सकता है, right? If you are talking about polar modulus, normally two types of modulus should run into your head. One is your moment of inertia, इसको बोलते हैं. But d square कैसे हो सकता है polar modulus की यूनिट तो देखो कम से कम. How can a section polar modulus में once polar section modulus, right? किसी मॉड्यूलस की यूनिट डी स्क्वायर कैसे हो सकता है? डी स्क्वायर तो एरिया होता है. डी स्क्वायर तो एरिया होता है. हाउ कैन इट बी डी स्क्वायर? थोड़ा कॉमन सेंस का अप्लाई किया करो. हाउ कैन इट बी डी स्क्वायर? सबसे इजी क्वेश्चन था. सबसे इजी क्वेश्चन था इसीलिए कट गया. समझ रहे हो? सो पोलर मॉड्यूलस इज बेसिकली द पोलर मोमेंट ऑफ इनर्शिया. नहीं, टू द पावर रॉन्ग है. अरे सुन तो लो यार, दोनों जगह पे क्यूब भी तो है. तो इफ यू आर टॉकिंग अबाउट पोलर सेक्शन मॉड्यूलस, तो पोलर सेक्शन मॉड्यूलस इज गोइंग टू बी योर पोलर मोमेंट ऑफ इनर्शिया बाई डी बाई टू. तो पोलर मोमेंट ऑफ इनर्शिया कितना होता है? पाई बाई 64 डी टू दी पावर 4 प्लस पाई बाई 64 डी टू दी पावर 4, है ना? आई एक्स एक्स प्लस आई वाई वाई, उसी को तो पोलर मोमेंट ऑफ इनर्शिया बोलते हो आप लोग. बाई डी बाई टू, सो इट्स पाई बाई, सुन तो लो, by d by 2, it's pi by 16 d cube. The correct option is C. स्मॉल स्क्रीन में नहीं दिख रहा है. अच्छा तो बताओ जूम करने के लिए. समझ रहे हो? सो दिस इज द पर्टिकुलर आंसर, राइट? सो बी केयरफुल रिगार्डिंग. क्वेश्चन इजी होता है बट थोड़ा केयरफुल रहो, स्पेशली फॉर दिस टाइप ऑफ क्वेश्चन. देख ले सब लोग पता नहीं है डी स्क्वायर में पावर ने काट दिया. हाँ तो कॉमन सेंस है ना भाई, डी स्क्वायर कैसे हो सकता है मॉड्यूलस का यूनिट? So this is the homework question for all of you. Take the screenshot on the count of 3. 3, 2, 1. Boom. Okay. So in case you haven't subscribed to our program yet, तो जल्दी दोस्त Gradeup Super को subscribe कर लो to get the best pool of faculties at a very affordable rate currently. Because सही prep है तो life set है, हम सभी को पता है. And just do join Gradeup Super in the month of March. Because in the month of March, we are offering you very exciting discounts on the particular thing that is, just like this, up to 50% off you can get. आप देख रहे हो वहां पे you are getting 50% off. Just tap on this and you will get some exciting scratch cards. Just scratch on it, you can get up to 50% off on all of our subscription till the March end. So yesterday itself I had won 40%. So I was thinking that let's try it. हाँ जी, कोई तो आने वाले हैं बिल्कुल, हमारे सहयोद्धा होंगे वो लोग. ठीक है. सो थैंक यू एवरीबॉडी फॉर बीइंग हियर. तो एक बार कमेंट सेक्शन पे हो जाए कि सही प्रेप है तो लाइव सेट है. ठीक है. थैंक यू. This is Aniruddha signing off from the largest live learning platform of India. Meeting you very soon with some very exciting series exclusively on Gradeup app as well as on YouTube channel. So prep smart, go better, go Gradeup and sahi prep. Thank you.